Module 9 relates to what we call rational expressions. And a rational expression is nothing more than one polynomial divided by another. But as soon as that division symbol gets in there, which looks like a fraction bar, it means that everything that we know about how to attend to the algebra of fractions is going to come back to haunt us / help us. When we think about the algebra tools that are necessary to work with these kinds of expressions. So I kind of want to start, and maybe I'll just ask this question to all of you collectively before we break into smaller groups and look at some more detailed problems. I kind of want to just start by asking, how would you simplify this fraction, quote unquote, this rational expression, this ratio of one polynomial divided by another? What would be your thought process, your decision process for simplifying this thing, Robert?
Distribute the top and the bottom.
All right, so one school of thought would be, let's multiply out the numerator and the denominator. Whoops. So that would require me to, probably what I would do is I would FOIL what's here, and then multiply that by 56, and I would FOIL this, and multiply that result by 7. Let me see if I can do that. So if I were to do all of that foiling on top, I would end up with 2y squared minus 8y minus 7y, so minus 15y, plus 28, and then I would multiply that by 56, and then down in the denominator, I would multiply 2y minus 7 by y plus 8 to give me 2y squared minus 7y plus 16y. So now 16 minus 7, that's 9, minus 56. So then I would need to multiply that 56 through everything. That's going to give me 112y squared minus 56 times 15. It's going to be 560 plus 28 is 588. Y plus 56 times 28, oh gosh, that's going to be 1,000 plus 120 is 1,120 plus 400 is 1,520 plus 1,568. You might have to double check my arithmetic. Then downstairs, 14y squared plus 63y minus 56 times 7, that's 350 plus 42, 392. All right, you should probably double check my arithmetic. But I'm going to claim to you that I just wasted 60 good seconds of your time, right?
Isn't there an easy way where it just cancels out the 2 lines?
Yes, thank you. Yes, exactly. Right. So anytime you're working with polynomials, there are two competing forces, things pulling you in two opposite directions. On the one hand, there's the force that says, I want to FOIL everything out and multiply everything out so I can see each term individually in the polynomial. That was the instinct that Robert just followed, right? On the other hand is the impulse to factor, to leave everything factored. We won some very hard-fought battles in Module 7 and 8 learning how to factor polynomials because they give us a different perspective on how polynomials are put together by bringing multiplication to the forefront instead of addition and subtraction, which is what's brought to the forefront here. Right? And if we're thinking about simplifying a fraction, we don't care about addition and subtraction at all. We care more about multiplication and division because division is what makes a fraction a fraction. Okay? So there is a time for everything. Season, to everything there is a season, and a time to every purpose under heaven. Are those the lyrics / the citation from the Bible? There's a time to FOIL, and there's a time to factor. When working with rational expressions, the time to FOIL is almost never. The time to factor is almost always. Okay. So I guess my first exhortation to you in working with rational expressions is to leave everything factored until the last possible minute. Because it's only in its factored form that we're going to understand kind of how this fraction is put together until the last possible moment. Which means that all of the foiling work here that we did is something we probably don't want to do. And the reason we don't want to do it, let me just make a metaphor here. The reason we don't want to do it is, let's suppose that instead of variables, I just had numbers in my fraction for a moment. So how about 10 minus 8 divided by 10 minus 6? If I just had this fraction, is there a way that I could simplify this that jumps out to you? Right?
Cancel the 10, cancel the
Yeah. So that would be the sort of the impulse, right? If I wanted to simplify, my instinct might be to just cancel out the 10s. Right? Let's just start by canceling out the 10. I suppose we could also cancel the minuses. If I did that, I would get what value for this fraction? 8 over 6? What does that reduce to? 4 over 3? Okay. But on the other hand, what is 10 minus 8? It's 2. What's 10 minus 6? So isn't this fraction really 2 over 4? What just happened? So what is it? Is this fraction equal to a half, or is it equal to 4/3? Those are different numbers. Which do you believe? Why? Why do you believe 1/2?
It makes sense to subtract first and then.
Because why? In this expression. Yeah, I mean, so here's something that a fraction bar does that we don't always give it credit for doing. It groups together what's above it and what's below it. So it groups the 10 minus 8 together. It groups the 10 minus 6 together. And if we emphasize that by putting parentheses around the 10 minus 8 and the 10 minus 6, then we have the order of operations that comes in and says, hey, the stuff in those parentheses has got to be simplified before you even think about division. Right? In PEMDAS, the P comes before the D. So, because of that grouping function that is incumbent in a fraction bar, I'm with you. I believe this version of events. Right? I believe 10 minus 8 divided by 10 minus 6 should be a half and not 4/3. And yet, where people go off the rails in working with rational expressions is that they do too much of this instinct here, which is to cancel things which we cannot cancel. It is not okay for us to cancel these 10s and this minus signs, because if we did, in this expression, it would give us a value for this fraction, which this fraction does not have. This fraction is not equal to 4/3. It's equal to a half. So can you pull a lesson out of that? When should we not cancel, and when should we cancel? Let me start with when not to cancel. What was the problem here? Why can't I cancel these 10s? John? Oh, yeah, you're right. Let me change the problem just a little to, instead of 10 minus 8 and 10 minus 6, let's suppose that I were trying to simplify the fraction 80 divided by 60. And in order to try to simplify this fraction, what would we do? I'm giving you a point of comparison here. Right, we would try to find some common factors. Maybe I would look at 80 and say that 80 is really 10 times 8. And I would look at 60 and say 60 is 10 times 6. All right, so maybe I can look at these and identify, hey, 10 is actually a common factor of these two integers. And what can I then do by virtue of having that common factor? I would divide both in the numerator and denominator by 10, the result of which would be to cancel the 10s and get 8 over 6. And here, I think we can agree, if we also then divide by 2, we get it down to 4/3. Here, I think we can agree that this cancellation is kosher. All right, this is fine, where this was not. So what's the difference? When is it okay to cancel 10s? When is it not okay to cancel 10s? What was the big fundamental difference between how these two fractions were put together? Robert? Have a guess? Gabby?
Yeah, subtraction and multiplication. So there's actually parentheses around the tens for the multiplying.
Yeah. So the big difference is in the arithmetic that glues these numerators and denominators together. In the fraction on the right here, the 10 and the 8 are being multiplied. And what is done with multiplication can be undone with division, and that's really what a cancellation is. Right? Cancellation is really a process of dividing away something from the numerator that's equally divided away from the denominator. So when I cross these 10s out, what I'm really saying is let's divide by 10 up here and divide by 10 down there. And in doing so, we cancel out the multiplication by 10. Whereas what's going on over here? 10 minus 8, 10 minus 6?
Subtracting from 10.
You know, I'm subtracting from 10. I'm using addition and subtraction. So if I were somehow magically able to cancel these 10s, I wouldn't be able to use division to do it. Right? If I divided by 10 up here, then this 10 would turn into a 1. This 8 would turn into 8 divided by 10, 4/5. So now things are getting more complicated than we were imagining them, right? This 6 divided by 10 would turn into 3/5. And that would be fine, but that hasn't achieved the cancellation that we thought we were achieving, right, when we just cross the 10s away. So what we may cancel are factors. When a quantity is multiplied, when a quantity is being multiplied equally in the numerator and in the denominator. Equally upstairs and down. Right? Like the 10 was being multiplied equally upstairs and downstairs in 10 times 8 over 10 times 6. When not to cancel is, well, I suppose we could say literally any other time. But I want to put a finer point on that here, because the most tempting targets for bad cancellation are quantities which are added or subtracted. Even if it's added or subtracted equally in the numerator and denominator, we still cannot cancel it, right? Because addition and subtraction they're not compatible with division and multiplication in that way. When a quantity is added equally upstairs and downstairs. Right? So I can't cancel those 10s. I could cancel these 10s. And so another thing that will sometimes happen when we take it out of the realm of numbers and into the realm of expressions is somebody might see, let me ignore this 56 and the 7 for a minute, and just focus on this part of the expression. What I'll often see students do when they're looking at this ratio is just say, and I've seen this happen on a number of people's final exams this semester, and don't feel bad because we hadn't had this conversation until now. But this is what often will happen. People will take those two y squareds and say, oh, it's upstairs, it's downstairs, it's gone. What's wrong with that logic? How is the 2y squared being connected to the rest of its expression here? Subtraction and addition. And that's no good. The fact that that is not a factor but a term in the numerator and denominator makes it an illegal target for cancellation. We can't do it. It doesn't work. So the only things we can cancel, maybe here's an even more specific, finer point to put on it. We can only cancel what is a factor. We can only cancel factors, not terms. Never terms. Factor here meaning a multiplicative piece of an expression. Term meaning an additive or subtractive piece of an expression. And so, coming completely full circle around to this, it means that in the tug of war between trying to factor everything and trying to FOIL everything, we want, as long as possible, to factor. Factor, factor, because it's only after factoring that we know what we can cancel. Foiling does the opposite. It obscures our vision for what the factors are upstairs and downstairs. And only common factors in the numerator and denominator might be canceled.